Today we'll see how to solve the particular example by using hypothesis testing. Let us consider the example. Consider the following hypothesis test where H0, that is null hypothesis, is given as mu equal 14.32 and alternative hypothesis is mu not equal to 14.32. Okay. A sample of 75 provided a sample mean of 14.68. So whatever information is given, first let us write that thing. So first of all, the hypothesis is given. So we'll write hypothesis. So what is written? What is given? H0, that is null hypothesis. Mu is equal to 14.32. Okay, and alternative hypothesis is mu not equal to 14.32. We know that whenever null hypothesis is equal and alternative hypothesis is not equal to type, then this is called a two-tailed test. Okay. Now, what else is given? Sample. They are talking about sample. A sample of 75. So first write it down. What is from sample? What is given? A sample of 75. It means they are talking about the size of sample. Size. The sample size we denoted by n is given to be 75. What else is given? A sample of 75 provided a sample mean of 14.68. So again they are talking about sample. So mean. This mean is for sample, which we denote by x bar. It is given to be 14.68. This information we have from sample. Now, next thing. The population standard deviation is 1.45. So let's see about population. Okay, from population what is given? Standard deviation. Also we know that when in the null hypothesis, this mu represents the mean of population. So first we write mean of population, that we denote by mu is equal 14.32. And from this line we get the standard deviation. Standard deviation of population we denote by sigma is 1.45. Okay, this information is given. Now what is asked? Compute the value of test statistics. Now from here we can see that for population we have mean and we have standard deviation. So this implies that we need to use Z test, because whenever mean and standard deviation are given for population, it means we have to use Z test. To use Z test, we need to use the rule, we need to calculate Z value, which is given by Z equal x bar minus mu divide sigma divide root n. Okay, now we have all these values, we substitute it over here. X bar is 14.68 minus mu is 14.32 divided by sigma is 1.45 divided by root n, square root of 75. You can use calculator to get the value. If you calculate it, it comes out to be 2.15014, which is positive. Okay, so our calculated Z value is 2.1504, which is positive. Now next thing, using alpha equal to 0.01, what is your conclusion? Alpha is given as 0.01. We use alpha, that is level of significance. It is 0.01. We use this to get to do the conclusion. So for that, first we need to get the critical region. Now, since it is a Z test which is two-tailed Z test, alpha equals to 0.1. If you remember the table, we have a table. This table gives you the critical values per se. So first of all, look at this table. If it is a two-tailed test, then and if the value of Z is positive, the critical region is Z greater than equal to Z tab. So what we'll write here? Critical region is Z greater than equal to Z value from table. Since Z comes out to be positive, our Z is positive. Okay. Now from the table, at alpha equal to 0.01 and two-tailed test. Two-tailed test this one, and alpha equal to 0.01 or 1% level of significance. The value from the table, the value of Z from the table is 2.58. So the critical region is Z greater than equal to 2.58. So what does it means? It means that the Z value which we calculated here, this one, if it comes out to be more than 2.58, we reject the null hypothesis. Otherwise, we will accept the null hypothesis. Now, if we check our thing, our Z value is Z value, that is that we calculated by calculation. So this value comes out to be 2.15014, and what you can say, this value 2.15014, this value is less than 2.58. So what this implies? This implies that our Z value is less than, so it does not lies in critical region. Does not lies in the critical region. So in this case, what we will do? If it is not lying in critical region, we accept the null hypothesis H naught. H naught. That is, we conclude that mean is equal to 14.32. Okay.